For centuries, Venus has been both a mystery and a warning. To the naked eye, it shines as the brightest planet in our night sky, a golden beacon second only to the moon. But behind that beauty lies a world of hellfire. A place where clouds rain acid, winds scream faster than hurricanes, and the surface melts lead like wax. Venus, named after the goddess of love, is, in truth, a planet of fury. It is almost the same size as Earth, the same mass, the same density. Astronomers once called it Earth's twin. But what we found was a nightmare version of our own world. The atmosphere of Venus is crushing, 90 times denser than Earth's. Imagine standing at the bottom of an ocean, but surrounded not by water, but by poison. Carbon dioxide makes up more than 96% of the air, and within it floats a deadly mist of sulfuric acid. Sunlight filters through this haze, trapped by greenhouse gases, turning the planet into a furnace. The surface temperature, 460 degrees Celsius, hotter than Mercury, even though Venus lies twice as far from the sun. In the 1950s and 60s, scientists dreamed of finding jungles beneath its clouds. They imagined oceans and rain, a paradise hidden by mist. But radar scans shattered the dream. When the Soviet probe Venera 7 landed in 1970, it transmitted data for only 23 minutes, before being crushed and burned by the inferno around it. Later missions, Venera 9, 10, 13, sent back the first real images from another planet's surface. They revealed a yellow world of shattered rock and endless plains, lit by a dim orange glow. The air pressure, 90 atmospheres. The temperature, enough to melt zinc and tin. And yet, for a few brief moments, those Soviet landers survived. They became our eyes in hell. The winds in Venus's upper atmosphere blow at over 300 kilometers per hour. The planet rotates backwards, opposite to all other major worlds. One day on Venus lasts longer than its entire year. The sun rises in the west and sets in the east. It is a world where time, heat, and chemistry have rebelled against life itself. A world that shows us what happens when the greenhouse effect runs out of control. Venus is not only a planet, it is a mirror, reflecting the possible future of our own. And yet, the story of Venus is not just one of destruction. It is also the story of curiosity, of human persistence. For even in that inferno, we found mystery. Lightning that flashes in acid clouds, volcanoes that may still erupt, and traces of chemicals that might, just might, suggest something alive, high above the deadly surface. This is Venus, Earth's twin, turned into its warning. A planet that was once like us, but lost its balance and became a furnace of storms. Life above the inferno. High above the burning plains of Venus, there lies another world. 40 to 60 kilometers above the surface, temperatures drop to those we could survive. The pressure nearly equal to that at sea level on Earth. Astonishingly, amid the acid clouds, there is a zone of balance, a region scientists call the habitable layer. It is a haunting idea, a world where life, if it exists, would never touch the ground. It would live in the clouds, drifting among droplets of sulfuric acid, feeding on sunlight, wind, and chemistry. For decades, this was just imagination. But then, in 2020, something extraordinary happened. Astronomers using powerful telescopes, the James Clerk Maxwell Telescope in Hawaii and ALMA in Chile, detected faint traces of phosphine gas. On Earth, phosphine is produced in only two ways: by industry or by microbes living without oxygen. To find it on Venus was like hearing a whisper from another biosphere. The discovery electrified the scientific community. NASA, ESA, and JAXA scrambled to re-examine archived data. Japanese orbiter Akatsuki observed strange ultraviolet patterns in Venus's atmosphere. Soviet archives from the Vega and Venera missions were reanalyzed for hidden chemical clues. But as quickly as excitement rose, doubt followed. Some scientists proposed the signal came from instrument errors. Others argued it was sulfur dioxide, not phosphine. The debate still continues, and no explanation fits perfectly. The truth remains hidden, somewhere within those deadly clouds. Still, the idea refused to die, because Venus has always challenged what we think we know about life. In 1978, NASA's Pioneer Venus mission sent 4 small probes plunging into the atmosphere. Each transmitted data as they fell, measuring lightning, winds, and mysterious particles that scattered sunlight in unexpected ways. Those signals hinted that something complex, maybe even organic, could exist there. Later, in 1985, the Soviet Vega balloons floated for 46 hours in the upper clouds of Venus. They recorded wind speeds, temperature shifts, and atmospheric waves, and even captured faint acoustic vibrations, the sound of Venusian storms. It was the first time humans had ever drifted in the atmosphere of another planet. Modern missions continue to explore these mysteries. Japan's Akatsuki orbiter, launched in 2015, still studies Venus's strange super-rotation. Its winds racing around the planet every 4 Earth days, faster than the planet itself spins. NASA's Magellan mission, decades earlier, had mapped nearly the entire surface with radar, revealing thousands of volcanoes. And new data suggests some of them might still be active. In 2023, scientists studying Magellan's radar images found changes in volcanic vents near Mont Mons, evidence of a possible recent eruption. If true, it means Venus is not a dead world, but alive with fire beneath the clouds. Imagine this, a planet where volcanoes breathe out gases into acid skies, and the lightning flashes through sulfur clouds. Some researchers believe those electric storms could create phosphine naturally. Others argue they only deepen the mystery. But what makes Venus truly captivating is what could come next. NASA's upcoming Da Vinci mission will dive through the atmosphere, sampling its layers directly, measuring gases, chemistry, and pressure all the way to the surface. ESA's Envision orbiter, planned for the 2030s, will peer beneath the clouds using radar far sharper than Magellan's, searching for geological change and perhaps signs of volcanic life cycles. And the private Rocket Lab mission, Venus Lifefinder, aims to send a small probe that will fly through the upper clouds, sniffing for organic molecules. For the first time, we might truly test the dream that life can exist above hell. Even now, Earth-based telescopes continue to watch Venus closely. They've detected rotating patterns, massive atmospheric waves that circle the planet in mere days. Some stretch over 10,000 kilometers. Others pulse with an unknown rhythm, almost like a heartbeat in the clouds. And beyond the science, there's beauty. Venus glows like no other world. Its clouds shimmer with golden light, reflecting nearly 80% of the sunlight it receives. If you could stand on the surface and look up, the sky would be orange. The sun, only a dull glow. But above those clouds, the view would be breathtaking. A sea of golden mist, lightning flickering in the distance, the curve of the planet glowing faintly below. This layer, between destruction and possibility, is the key. Because it's here, in this narrow band of air, that the conditions most resemble our own world. Pressure, warmth, light. And where those three meet, life always finds a way. Venus may have once been alive, and perhaps, in its skies, it still is. And if we find even a single living cell drifting in that alien sky, it would rewrite everything we know about the universe. For in that moment, we would learn that life is not unique to Earth. It endures, even in the most impossible places. Beneath the blinding clouds of Venus lies a planet of secrets, a world shaped by fire, crushed by pressure, and forever hidden from direct view. Thanks to radar and spectral imaging, scientists have slowly unveiled what no human eye could ever see: a vast and tortured landscape. mountains the size of continents, plains of hardened lava, and valleys carved not by water, but by molten rock. The surface of Venus is geologically young, no more than 500 million years old. That means the entire planet may have been resurfaced, melted, flooded, and reborn by cataclysmic eruptions. Some researchers believe that Venus goes through cycles of global destruction. Every few 100 million years, its crust melts down. Oceans of lava erase all traces of the past. Then, slowly, the surface cools again, until the next planetary reset. Among the most striking features are its vast volcanic rises, like Ishtar Terra in the north and Aphrodite Terra near the equator, highlands that rival Earth's continents in size. Towering above them is Maxwell Montes, the highest mountain on Venus, reaching nearly 11 kilometers above the average surface, higher than Everest. Yet here, temperatures still melt lead. Even the mountaintops burn. Unlike Earth, Venus has no tectonic plates sliding beneath its crust. Its surface doesn't recycle like ours. Instead, the planet breathes through massive fractures, immense circular structures called coronae, formed when heat from the interior pushes upward, cracking the crust like the shell of an egg. Some coronae stretch hundreds of kilometers across, glowing faintly in radar reflections, silent signs of the planet's inner turmoil. Deep below, Venus hides another mystery, its core. Roughly the same size as Earth's, made of iron and nickel, yet almost completely still. The planet's slow rotation and thick mantle have silenced its magnetic field. Without that invisible shield, solar radiation bombards the atmosphere freely, stripping particles into space. Over billions of years, this may have been one of the reasons Venus lost its oceans. And yes, there are clues that it once had them. Data from isotopic analysis show that Venus contains far more heavy hydrogen, deuterium, than Earth. It's a telltale sign that vast amounts of lighter hydrogen escaped into space, leaving the heavy atoms behind. In simpler terms, Venus once had water, maybe entire seas. But as the sun grew hotter, water vapor thickened the atmosphere, trapping heat. The more the planet warmed, the faster its oceans evaporated. A runaway greenhouse effect turned paradise into a furnace. Studying this process isn't just about Venus, it's about us. Because the same mechanisms that destroyed that world exist here on Earth. The difference is only a few degrees. NASA climate models built for Earth have been used to simulate ancient Venus. They show that, for up to 2 billion years, Venus might have had shallow oceans, clouds, and even gentle rain. Only later did volcanic activity and sunlight push the balance past the point of no return. And that is why scientists call Venus Earth's warning. A reminder that climate is fragile, that even a twin planet can fall into irreversible heat. Yet, in that tragedy lies purpose. Venus is now a laboratory, a natural experiment showing what happens when the atmosphere becomes too thick, when carbon dioxide rules the sky. Every reading, every mission helps us understand how to protect our own planet. Even the harshest data can inspire hope. Because if Venus once had oceans, it means planets with similar size and distance from their stars could hold life elsewhere in the galaxy. Billions of exoplanets orbit suns like ours, and many of them might be balanced between the fates of Earth and Venus. We call this narrow region the Venus-Earth boundary, the line between paradise and inferno. It's the most valuable lesson our sister planet gives us, how thin that line truly is. Venus also reminds us of our limits, but equally of our potential. Every probe that entered its atmosphere, every radar pulse that mapped its surface, every scientist who dared to imagine life in acid clouds, all of them added to a human story older than technology itself. The story of our curiosity, of our need to understand, even when understanding burns. One day, new missions will dive deeper, last longer, and maybe even send balloons that can drift for months, studying the clouds from within. And perhaps, decades from now, the first human eyes will see the surface of Venus through protective glass, gazing upon a world that once was like ours. Not as conquerors, but as witnesses to what was lost and to what we still have the power to preserve.